So we have an idea of what the browser does with our JavaScript code, how it technically is able to execute that, how it compiles it. But if we take a closer look, if we zoom in into our code execution, how exactly does that work? I don't mean the technical aspects regarding the code getting compiled, but how the different steps in our code, how the logic there is executed. So let's look inside the JavaScript engine, the thing that executes our code. And there, it's in the end all about managing memory and managing execution steps, you could say. And for this, we have two important concepts, the heap and the stack. Now, what are these concepts? What's the idea? The heap is our long-term memory, if you will. It's all about memory allocation. It stores data in our system memory, and with it, I mean the browser does that. The browser manages this heap thing, the browser taps into our system memory, and of course our operating system has a say in that as well. It allocates memory to the browser application, so that's the bigger picture. But if we zoom in into the browser and then into the JavaScript engine, in the end, the browser does this memory allocation in that thing which is called a heap. So there, data gets stored with which we work in our program, and important long-term data. And then there is this stack thing. Now that stack thing is in the end important for the execution of our code. Of course, the data is also important for that, but the stack is kind of the short-term memory, if you will. It manages our program flow, and mainly that means that the stack keeps control over which function is currently executing, and when we execute a new function, that this function is now executing, and if a function returns, to which function it returns that data. Now this becomes much clearer if we simply have a look at an example. And for this attached, again, you find a very basic starting project with an HTML file that's basically empty. All it has is a script import. And then we have this script. So there are no real elements on the screen. There are no styles. It renders this empty page because now we'll just have a look at some of the behind the scenes things where we can use the developer tools, for example, the console, to get a feeling for what's happening. So now here, let's write a basic program to get an understanding of what's happening. In this basic program here, I want to have a function which I'll name greet. And in this function, I want to say hello. And I don't just want to say hello, I also want to get the name of a user. So I'll have my username constant, and that value should be fetched by another function. So here I'll add another function which I'll call getName. And in this getName function, I return the result of us prompting the user for the name. So your name in this prompt here opens this dialog where we have to enter something, then prompt returns that value, and then I return the value returned by prompt to whoever called getName, which in my case will be greet. So here I call getName, so whatever we enter into this prompt will in the end up in username, and then I output this here in the console. Now last but not least, I just call greet down there. Otherwise, these functions would only be registered but never executed, right? That's what you already learned. This defines functions. JavaScript then registers them. You could say it stores them in the heap because these functions have a long life typically. They live as long as you do something in your application. And here we then call such a function. Okay, so with that, if we save this and we reload this page, I get prompted here. I can enter max, and if I do so, I print hello max here. Now, how does this relate to our stack heap thing here? As mentioned, the functions themselves are basically stored in the heap, so that's where the browser stores these functions and the code it should execute when these functions are executed, you could say. And now when our script runs, the stack is getting active, or to be precise, the browser in the end pushes stuff into our stack. And remember, the stack is basically our short-term memory. Heap is the long-term memory. Now in the stack, it all starts with some anonymous code execution, which basically is the script file itself. It doesn't have a name. of course, the file has a name, but it's like in a big, gigantic function to which you didn't assign a name. So the code directly in the file is in a function without a name, you could say, and therefore we have this anonymous execution in our stack. So that's the overall script which is getting executed. Of course, that execution of our script only happens after JavaScript evaluated the entire script and, for example, saw all the function definitions. That's what I already explained earlier in the course. So the script execution started, we're executing the entire script, and that basically means that this greet line is getting executed. So we call the greet function. Therefore, JavaScript moves this greet function execution onto the stack. So the stack is in the end a data structure, a short-living data structure, you could say, where your function executions are stored, so to say. So where the browser or the JavaScript engine keeps track of what's currently happening. And the stack is simply populated by pushing new function calls or new short-living data on top of it and popping it off when it's not required anymore. So we started with the overall script execution, this anonymous function, and in there we called the greet function, hence this is pushed onto the stack and is now the topmost item in the stack. And the topmost item in the stack is always the thing which is currently happening, you could say. Now, if we have a look at the greet function, what happens there is that we create a variable, and that variable is created by calling yet another function, the getName function. So now the JavaScript engine pushes this getName function execution onto the stack. Therefore, it now knows this is the currently running function. It was started by the greet function, which in turn was started by this anonymous function, so by our overall script. This is how JavaScript or the JavaScript engine can also keep track of the relations of these function calls. So which function called what? So getName is running. Now what happens next? In getName, we return the value of prompt. Now, technically, we therefore also call the prompt function, which of course is not a function written by us, but a function provided by the browser, which we can access through JavaScript. But still, this is a function call, and therefore this also gets pushed on top of the stack. And it would continue like this. The more functions you call, the more gets pushed onto the stack. Now, what happens next? Prompt opens that dialog, and once we entered something there and we clicked OK, or also when we click cancel, prompt actually returns this value to getName. Now, when a function returns or is done executing, it's popped off the stack, which means it's removed from the stack. It's removed from the short-term memory because it's done. Now, important, that does not mean that the function definition is removed from the heap, from that long-term stack. Just this current execution, which of course also involves resources that need to be allocated and data that needs to be managed for this function execution. That data, this execution context, therefore, is removed from the stack. Now in getName, we therefore get that result from this prompt function call. And what do we do with it? Well, we also return that. So getName returns the data to the greet function. As a result, getName also gets popped off the stack. Whenever a function returns a value or simply is done with all its steps, it's removed from the stack. It's popped off the stack. The JavaScript engine does that for us. Now, after being popped off, so getName was popped off, we're in greet. Now greet continues running. We don't have a return statement in there, but once the function executed its last line that's part of the function, it implicitly returns, so it automatically returns. So therefore, once this is done, greet is also popped off the stack, which leaves us with the main script, with the script itself, which you could imagine as being wrapped by a big anonymous function. And now in this script, clearly, once we're done with greet, there's no other step left, right? There's nothing after greet, no other steps left, so we're done with this overall script execution. So therefore, we also pop this off. And that means we're done with everything that needs to be executed at the moment. We can also see that in the browser. Of course, we see the result in the console, but if you go to sources and then to your script file there, we worked with that earlier in the debugging section, you can actually place a breakpoint and place one here inside of getName by clicking on this line number 2 in my case. If you now reload the page, it stops execution at this point of time. And if you now expand this, you actually see the call stack here. This is exactly the stack I was talking about. Not the full stack, because the stack memory itself does actually not just manage function calls, but also short-living values stored in variables. But it shows us the order in which the functions were executed and how they're managed as a stack. And this is just the stack I was just referring to. And here you see getName, before you see greet, and then you see this anonymous thing at the bottom. Now getName is about to call prompt, and we can actually see that by stepping into the next function call, which opens this prompt here. And there, if I enter max and hit OK, well, we're back to getName. Unfortunately, here it never shows prompt being called, but prompt would be pushed on top of the stack as well. And now if I continue here, and I step out of the current function call, for example, we're back in greet. Therefore, getName was popped off the stack. If I step out of this function call, well, then we're back to anonymous because greet was popped off the stack. And if I now resume script execution, eventually the call stack is empty. So that is how this in the end works. This is how JavaScript manages the data and the execution context, the order of execution, and this is how it therefore works under the hood. Now you might remember from the first course section that there I mentioned that JavaScript is single-threaded. Now without getting too technical, that basically means that JavaScript can only do one thing at a time. That's exactly what happened here. It called one function at a time and the other functions waited for the response of that function, just as you saw it in its stack. So the stack and this idea of managing our function calls and the flow of the script therefore in such a stack, that basically ensures that this single threading thing works and that the order of execution is ensured and that every function basically knows to which function it relates. Now there is one other important concept which is actually not part of the JavaScript engine, but of modern browsers like the Google Chrome browser, but also of other browsers. And that's a thing called the event loop. This will actually help us with asynchronous code, which we haven't really learned too much about yet. It helps us with things like event listeners, these click listeners which we added to buttons. The current picture which you have here, where we have this stack which does stuff and which eventually is empty, kind of implies that a script always has a certain point of time where it's just done with everything. Just like this script actually is. It's done after line 10 executed. But that's not necessarily always the case for all scripts. What about a script like this? And you find this setup attached as well. It's this index.html file, which has a bit more content. It has 2 buttons and this app.js file. Let's not worry too much about what's happening here. I'll come back to this script and about an issue which it actually has later in this module. But the main thing which is important to us right now is that here we're actually adding event listeners. We're adding event listeners here to buttons. And that, of course, therefore means that if we would actually execute this, and I remove this breakpoint here, and instead I set a new one in app.js, and I set one here at the end at line 14 when we register this event listener, and now I reload, well then of course execution pauses and we have our call stack down there. Right now I'm not pausing inside of a function, so the anonymous wrapping function is the only thing on there. And if I resume, the call stack is empty here as well. Now this would imply that this script is not able to do anything ever again. And still, if we go to the console and you enter something here in the input, click add a listener and then click me, you see this actually still does something. This output here is coming from our script from line 7. So this script is still alive even though we're at the end of it and even though our call stack is empty. So that can be confusing. Why is that happening? Well, that's exactly what that event loop is about. We'll dive into that in way more detail later once we learned more or learned something at all about asynchronous code in JavaScript and what this is and what the opposite is. For now, you can just keep in mind that there is something else in the browser, not in the JavaScript engine. The engine is really just that heap stack thing. But in the browser, which communicates with the engine, of course, which is this event loop. And in the end, you can imagine these click listeners as information being passed to the browser. So therefore, the JavaScript engine does not care at all about these ongoing listeners. The browser manages them. And the browser basically pings the JavaScript engine, you could say, whenever it has a new event being fired by the listeners set up by the JavaScript code. So the browser kind of manages these listeners, and whenever such a listener triggers, whenever a button is clicked, which of course is part of the web page rendered by the browser, so the browser knows when that happens, whenever that happens, it basically pushes that information to your script, you could say. And it does so with the help of that event loop, which is there to control that this pushed event does not interrupt with your ongoing script, which might be running, but instead is executed in order once your call stack is empty. But again, we'll have a detailed look at this event loop thing in a later module after we learned about asynchronous code. The JavaScript engine itself is this heap and stack thing here.